Hello listeners, in our previous video we have discussed about introduction of irrational number and we have discussed some theory to prove that root 2 or some numbers as an irrational number, and in this video we will discuss how by using that theorem how you will prove that that number is an irrational number. Okay, root 2 is an irrational number. You will use method of contradiction. Method of contradiction. Contradiction. What do you mean by contradiction? Means we assume that number is wrong. Okay, we will consider as wrong. Okay, means it is wrong and we are making it right. Some calculation we are doing and you will get the result as wrong. You will get the result as wrong. If you are getting the result and wrong, you will say that our assumption is wrong. Okay, our assumption is incorrect. This method is called as method of contradiction. Okay. We have to prove that root is a irrational number, but we are saying that root is a rational number because we are using a method of contradiction. Okay. Then what we said that we are making it into a p by q. Rational number means it must be in a p by q form. Whenever you are telling that that number is a rational number, it must be in a p by q form where p comma q are integers and q should not be equal to 0. It must satisfy this condition. So we are saying that let p comma q have some common factor. So by cancelling them we will get a upon b where a and b are co-primes. What do you mean by that? We will do. Okay, just take an example. P as 15, q as 25. Then we are saying p by q. P by q means 15 by 25. What factors you are getting? 3 into 5, 5 into 5. You are cancelling common factors. So what is left? What is left is 3 by 5 means let p by q have some common factors. What are the common factors? We are cancelling. So what you are getting? We will getting a by b means 3 by 5 where a and b are co-primes. You are making this as co-primes. What do you mean by co-primes? Means no common factor other than 1 is called as co-prime. So let p by q have some common factor. So by cancelling them we will get a upon b where a and b are co-primes. With the help of example we prove that we cancel some common factors and you will get some prime numbers that will be considered as co-primes. So what you will get as root 2 is equal to a by b means cross multiplication. What you will get? Root 2b equal to a. Okay, what you have to do? Squaring on both sides. You have to do. Whenever you are doing squaring on both sides, what you will get? 2b square is equal to a square. This is your first equation. Okay, first equation. Then one more equation, what you will do? Okay, b square, just take b square. What you will get? A square by 2. It means that a square by 2. What you mean with 2 divides a square. When 2 divides a square, it means that 2 divides a also. It also means, in our previous theorem we discussed that when p divides a also. When p divides a square, p divides a also. So what you will get? A by 2 equal to c. Then what is your a value? A equal to 2c. A equal to 2c. So what we said that a equal to 2c. So squaring on both sides, what you will get? A square equal to 4c square. So put value of a square in equation 1. Okay. What is your equation 1? 2b square equal to 4c square. 2 2 are 4. So what you will get? B square equal to 2c square. So what you will get? B square by 2 equal to c square. You will get that value. Okay. What you will set? 2 divide b square is nothing but 2 divide b. Okay. Previous also we are getting 2 divide a square is equal to 2 divide a. It means that 2 divide both a and b. Both a and b. Both a and b. It means that a and b have at least one common factor. At least one common factor. But we already cancel that common factor and we have taken co-prime. Okay. We have taken co-prime. But this contradicts the fact. Contradicts the fact that a and b are co-prime. Already we have taken the co-prime. Co-prime means after cancelling the common factors you are taking unique factor, but here we are getting the one common factor also. So it is wrong. Means it means that our assumption is wrong. Our assumption that root 2 is rational number is wrong. It means root 2 is a irrational number. Irrational number. With the help of theorem we prove that. So whatever we have thought, whatever our assumption is wrong. Okay. Let us do. Prove that root 3 plus root 5 is an irrational number. So we are using method of contradiction. It means that root 3 plus root 5 is a rational number. Okay. Is a rational number. So first we have to prove that it is right. After getting the wrong answer, you are saying that your assumption is wrong. So first wrong, right, wrong, that kind of contradiction method is there. Okay. Let root 3 plus root 5 is a rational number. Whenever you are saying rational number, it must be in the form of p by q. Okay. P by q form. Okay. Where p comma q are integers. Okay. It must be in integers. Okay. And q should not be equal to 0. Okay. P by q form. So squaring on both sides. Squaring on both sides. Okay. Squaring on both sides. Root 3 plus root 5 whole square equal to p by q whole square. Let's observe that it is in the form of a plus b whole square equal to a square plus b square plus 2ab. Okay. Root 3 whole square is 3. Root 5 is 5 plus 3 5s are 15 equal to p by q p square q square. Okay. 5 plus 3, how much you will get it? 8 plus 2 root 15 is equal to p square by q square. Okay. P square by q square. You can also write that root 215 equal to p square by q square. Send the constant value here minus 8. Okay, minus 8. Or you are sending this constant value here also. So what you will get? Root 15 is equal to 1 by 2 into p square by q square minus 8. Observe that it is in the form of p by q, means it is rational number. Okay, rational number. But root 15 is an irrational number. So it contradicts. It is not true. It is not true. Root 15 is a irrational number, but we cannot say root 15 is a rational number is wrong. Is wrong. Is wrong. Our assumption is wrong. Our assumption is wrong. Our assumption is wrong. Root 15 is an irrational number. Irrational number. Let's prove one more problem. Prove that 2 plus root 3 is a rational number. Okay, first we have to prove is a irrational number. Let 2 plus 3 is a rational number. Okay, we are assuming that this number is a rational number. If it is in a rational number, so it must be in p by q form. Okay, where p comma q are integers. It must be integers and q should not be equal to 0. This must be the condition. So what you are doing? Root 3 equal to p by q minus 2. Okay, p by q minus 2. Just observe that you can also write this by taking denominator. You can write it p minus 2q by q. It is in p by q form, means it is a rational number, but root 3 is a irrational number. But root 3 is a irrational number. So our assumption is wrong. Our assumption is wrong that root 3 is a rational number. It is it contradicts. It contradicts. Okay, so 2 plus root 3 is a irrational number. This is